Jalbrzikowski, but you can call me Jeff J. A lot of people call me JJ. Should be able to see my intro slide screen there. And I work for the National Geodetic Survey. I'm your Appalachian Regional Geodetic Advisor, as you see there. And I can interface you, get questions answered on anything you've got related to what we do at NGS, or just geodesy, map projections, that type of thing in general, or really any questions you've got about NOAA. I work for NOAA, but I don't have all the best contacts or best knowledge of the entire agency, but I've got a lot of contacts. If you have other questions, you can always reach out to me for those. So real quick, just to mention, I try to do this everywhere real quick, is that we are delayed on releasing the new datums. So we're talking about 2024, 25 at this point, due to various reasons, including, pandemic issues, flights for gravity collection, all that. The names will stay the same though, okay? So you'll still see 2022, all right, as part of the names. But will the US, so if you've heard of the US survey foot being deprecated or retired, that will still occur on schedule, right? With an effective date of December 31st, 2022, but it really won't affect anyone until much later when the new datums come out. Why is that? Because we're not going to change anything we do in regards to that US foot until the new datums roll out. Okay, so it's still officially retiring next year, but nothing will happen until the new datums roll out. Okay. So what's our mission at NGS? Real quick, it's to really, the bold red letters right there is what it is: build and provide access to the National Spatial Reference System, or the NSRS. And real quick, I'm going to put up a graphic that I guarantee all of you have seen before, but I'd like to just show that's where we are. That's the NSRS. That's where it sits. We're that invisible backbone that everybody ignores until you get a bulging disc or whatever, and you're like, oh, you go to the chiropractor, right? And that's when you're calling us going, oh, my data won't line up, I got a datum issue. That's the NSRS, the framework, right? Without a uniform datum across the nation, how would really anyone do efficient GIS work? You'd spend all your time just aligning everything, right? And so that's the way we think of it. It's a common and consistent geospatial framework, right? The foundational elements of the NSRS are mostly, everybody thinks about these top three: latitude, longitude, and height, or what we say elevation, right? Depending on what type of height. Sure, there's gravity in the background that helps us create those heights, and the national shoreline position is a responsibility of ours too. So when we think about latitude and longitude specifically, and heights, we think about the horizontal datums, NAD 83, 27. We think about the vertical datums too, hopefully NAVD 88 most people are using. And what a lot of people don't think about are down here, the state plane coordinates, right? And I'll talk more about that in a minute. So just like SPCS 83 replaced 27, 83 is going to be replaced by SPCS 2022, okay, along with that, right? So the positional components of the NSRS and how they relate, I kind of want to break down that whole latitude, longitude, height into the different heights, right? So first off, up here, we got the geometric component of the NSRS, which we used to call it horizontal, but nowadays with everyone using GPS, right, whether it's super accurate survey grade or even your phone, right, to get some coordinates, we consider that ellipsoid height, that raw height that's part of the GPS, is what's determined by your GPS receiver, is tied very closely to the latitude and longitude, okay? So we consider that to be the geometric component, right? And the true elevation, right, that we're talking about, the way water flows, or the technical term orthometric height, that's what we consider the geopotential component, okay? Because there's that gravity, geopotential being a gravity energy force, right? And that's our NAVD 88, right? And so today, though, really focused on NAD 83, North American Datum in 1983, which will be replaced by what? The North American Terrestrial Reference Frame of 2022, or NatRef. We made the acronym. We can tell you how to say it, right? And the first thing I want to start off is, again, kind of harping on that SPCS, or state plane coordinate system, because I get a lot of this comment from a lot of our user community. Hey, Jeff, none of this matters to me because I do all my work in state plane. And that's when I respond with, I try to respond courteously with this thought, but where does that person think the state plane coordinates come from. Because, and I hope a lot of you probably do realize it, but some folks don't, right? Our state plane coordinates for 83 come from NAD 83. Same with 2022, right? Nothing changes there, just a little bit different way of building these state plane zones, okay? And a shout out to Brian Bunch there, we talked about earlier at the awards ceremony. He did a great job designing those zones, the 2022 SPCS zones for the Commonwealth of Kentucky. So I know that a lot of people see that, they say, what happened to the datum? Why are you saying reference frame now, right? Well, we're trying to be more scientifically appropriate. How do we explain this though? I like to explain it this way, right? Point of view, frame of reference, that's easy to conceptualize. So if your reference frame, right, in NatRef is North America, then you or we're standing somewhere like we are right now, right, within North America, right? And we're seeing or visualizing how other places move from our point of view. We're imagining that we're standing still, even though we know really that the tectonic plates way below us are moving. We imagine ourselves standing still and see how everything else is moving in relation to us. That is the idea behind NatRef 2022, okay? And it's tied really closely to another reference frame or terrestrial reference frame, which is the International Terrestrial Reference Frame. I'm going to skip down to this definition here. It's a pretty good one right here. If you want to read that, approximately represents the motions of our tectonic plates. Huh? Here's another one though. I like this one. This is kind of me paraphrasing. It's a globally fixed frame of reference that enables professionals, users, whatever, to measure land motion anywhere on Earth. Let's just look at a cartoon of it. This is a beautiful concept cartoon of the ITRF. The ITRF being represented by that grid. You see the grid stays fixed while the continents move. And what do you see here? An epoch labeled. If you don't know what an epoch is, we're going to talk about that next, but it's time passing, right? So as time passes, the grid stays fixed. The tectonic plates are moving, all in different places, right? So what is an epoch though? People say, oh, epoch, whatever. Tomato, tomato, you can pronounce it however you want. The important thing that I want to know is that you understand it represents an instant of time, okay? It can mean different things to different people, different sciences use it, but the way we use it is an instant of time, right? Geodesy, we use a decimal date to Y like this because of our close ties to astronomy and astronomers or astronomists, whatever they are. They've been using decimal dates even longer than we have, right? So that's where it came from in geodesy. But I want you to really remember that epoch doesn't mean a decimal date, okay? An epoch doesn't have to be a decimal date, right? Incorporating epochs into your metadata or your data is what's important, not the format, okay, that you see over here. The format of your epochs is not important, right? Like I say right here, some others outside the geodetic field, they use a day of year with a colon. Some of them use a day of year, so that would be day 131. Some people use a day of year with a decimal. In our case, that's not what this number represents. It's a long technical discussion, which we won't have today. But that's the important thing to know is what the epoch you're using means and what the epoch of other data sets are. And for a lot of folks, for a lot of data sets, a calendar date is sufficient for like each feature data set or each feature class, right? Just a calendar date of when this was valid for. That's going to be enough for most people. We got to talk a little bit more about epochs, and now we're going to move into the two types of epochs that will exist in NatRef, but they don't yet exist in NAD83, okay? NAD83 uses this reference epoch, okay? This is an example of an Opus solution report, one of our products. And you'll see anytime you get one of these, if you've worked with it or seen a survey use it, you'll see NAD83, and you'll see this 2011, that's the realization, okay? And then you'll see an epoch. You'll also see this on our data sheets, this epoch of 2010, that's January 1st, 2010, okay? What is a reference epoch? Think of it as a fixed epoch, okay? It's so like with NAD83, like I just showed you, every time you look up something in NAD83, that 2011 realization, you're going to see this epoch, the 2010.00, okay, because it's a fixed reference epoch. So the whole nomenclature or metadata for a coordinate in NAD83 would be like this. You should list that geometric datum or reference frame, show that realization in parentheses, and truly you should list out the reference epoch, even though most of us, and I'll attest to it, I never really did that until I came to NGS, okay? Another thing I want to bring up real quick on the topic is that those other realizations of NAD83 do in fact have their own reference epochs, or as you see me abbreviated here, REs. So that's just kind of something I want to highlight and show you that it's just something that we don't call out because it's the same for anything expressed in NAD83 2007 realization has an epoch of 2007.00, right? But as we move to NatRef 2022, we're going to have to deal with, you probably will have to deal with anyway, survey epochs, okay? That's something that's used in the ITRF already. We don't use it now in NAD83, but you see this epoch represents what? It represents right up here, this date and time, okay? That was, this GPS data was collected, okay? So it's 2019.9185, December 12th, 7 p.m. or whatever the midpoint is, right? It's a survey epoch, okay? Well, what's a survey epoch? It's a timestamp for when a set of coordinates is generated, right? It's that instant of time, right, for when those coordinates were generated. So to really use the ITRF properly, you've got to include that survey epoch in it, right? Why am I putting this out for our ITRF, right? That's an international product. It's not ours. Jeff, what are you doing? This is supposed to be about NatRef. Well, it's just to highlight that that's kind of the way we're moving, is to align ourselves better with the ITRF, okay? So another example, there are reference epochs within the ITRF, but you have to use the survey epochs to really be able to properly make use of the data in ITRF, okay? So same goes for NatRef, or will go for NatRef when it's released, just like ITRF. We'll have these defined reference epochs every 5, if you notice, 5 years, or maybe we'll change it to 10, we haven't figured out yet. And we believe that this is what the majority of the GIS professional community will use, our reference epochs, mostly because for the majority of the country, especially the lower 48, the change that's present in this small amount of time, right, in a year's time from the reference epoch to this epoch here, this survey epoch, right, it's just not going to represent much coordinate change or much land motion, right? So we're picturing the GIS community embracing those reference epochs. So if you're familiar with the true terminology for changing coordinates, I'll briefly point out a conversion is when you change the type of a coordinate. So like latitude and longitude to state plane. A transformation is down here when you change the datum, okay? So moving from NAD27 to NAD83, that's a transformation. And there is a technical term for changing the epoch of coordinate or moving it through time. That is a propagation, okay? You propagate coordinates through time. So on any given Opus solution, you see what we've done here is we've transformed from ITRF to NAD83, and then we've propagated from this survey epoch over here to the reference epoch for NAD83 2011 realization, right? So this is what we're looking at, is transformation and propagation. How does that occur? In the background with some of our software. What do we call it? It's out there for you, available to use. It's called NCAT, the NGS Coordinate Conversion and Transformation Tool. There's a nice little single point version, not very useful for the GIS professional community. So let me move on over to this next tab, the multi-point conversion. This might be more up your alley. You upload an ASCII text file, you choose your inputs, your outputs, you format your ASCII like we show you down here. You've got some more options for what output coordinate systems you want. You upload the file, you get results, you download it. What might really interest you though are our web services that we have, okay? So we're gonna jump over to, when you click on that tab, this is where you'll end up. So not only do we have these API web services for NCAT, but also for some of our other products, okay, that are various purposes for those. So there's where you go to find out how to use these different NCAT web services to get different kinds of transformations or conversions. And this is what some output looks like in JSON, right? And again, not again, but for the first time, we really want your feedback on these web services. If you are using these and you do or don't like them, or you want to see things added or changed, please let us know. Use this email address. It's all over our homepage too. NGS.feedback@noaa.gov. That's your best way to tell us what you do or don't like, or anything you want to say. Okay. And something new to us, really, if you don't recognize, excuse me, this page, this is our GitHub page. We've got the code for NCAT up on GitHub, so you can build your own tools. We have some other things. Again, let us know what you think of it. So how do we really do this, replace N8083? Well, it comes down to these 4 items that I want to explain. First, we develop 4 reference frames, not just NatRef. Here's all 4 of them. Why 4? Because there's 4 tectonic plates within our country, right? And including our territories out here, way down here, right? Hence, there will be 4 of these plate fixed reference frames. But if you're working in and around Kentucky, really all you need to worry about is NatRef, okay? So we built those. Now we align them to the ITRF in 3D. What do you mean by that, Jeff? Well, currently this is what N8083 looks like compared to the ITRF. It's about 2¼ meters off, shifted away from ITRF 2014 or 2020, whichever one. They're very millimeters apart. And so we will shift the origin of N8083 up to align with ITRF 2020. That will be 3-dimensionally, that's NatRef itself. So same ellipsoid shape, just a different origin point. Okay, that's our 3D alignment. Now we've got to align in that 4th dimension. Why? The 4th dimension being time, right? Because we know that ITRF uses those dynamic or survey epochs, right? So it's a shifting, always, it's a static frame, right? So that means the land coordinates are constantly changing. So let's zoom in. What does it look like in the lower 48? It's a constant frame with a rotating plate. I like this little cartoon I made. Greatly exaggerated, of course, right? You see this counterclockwise rotation, okay? That's blue is represented by the ITRF. So what's NatRef going to look like? It's basically the opposite. It's a frame constant with the plate, just like this, okay? That's where we get the term or the phrase plate fixed, okay? So that's where we'll pick a point to align to, and then we will diverge from the ITRF. So what we're doing is we're aligning at that certain epoch and then removing all that tectonic motion from the ITRF to come up with that plate fixed reference frame. How do we do that? With 2 models. One set called these Euler pole parameters. Lenny Euler, old Leonard Euler back in the 1800s or something like that, came up with these Euler poles. It's not the North or South Pole, but you could think of it as your EPP, Euler pole parameters. So let's look at that ITRF and NatRef grids at the same time now on that same map. Okay, so there you go. See, blue is ITRF, stays fixed. Red is NatRef, moves with the continent. The green arrow is what represents those EPP or Euler pole parameters. Showing, kind of representing though that, or let me point out though, that to apply those EPP properly, you have to know the epoch, right, of the point of when it was collected. So you can figure out where on that arrow, what do you need to add or subtract, right? So you've got to know the epoch of data you're working with in NatRef. Whether it's a reference epoch or a survey epoch, you need to know which one it is, which epoch it is. There's another model that'll be built. I don't have time to go into the technicalities of the IFVM or intra-frame velocity model. It's designed to account for regional land motions. Okay, we'll have to stop it there for today's talk. But if you got questions about it, we have some resources out there you can read more, or we could go into it on a later date. So to kind of roll things together, we got NatRef 2022. The biggest thing I want you to take away is you got to know your epoch of your data. Okay, coordinates will be associated with the date the data was collected. Even if you decide to align your databases, your data sets to reference epochs, you need to know which one you're going to choose. When are you going to upgrade? Ingesting data from other sources, you need to know those epochs to properly combine them, right? Because combining the data from really different epochs, it will lower the accuracy of your data set. Might not really matter though, right? That's what I want to kind of get into now. So let's imagine briefly that it's 2039 and you are working on a contract with some data near San Diego. The data is in NatRef 2022, and that's what your contract says. We want it delivered that way. And you got this other data set that the agency you're working for provided you, and it's from 2028. There's a catch though, it's in PATREF, one of the Pacific Terrestrial Reference Frames, something that's really designed for California. So to get your data moved up to where you want it, you've got to take one of these, whoa, confusing, complex paths. It's frustrating, right? But that's where, whoops, wrong click. That's where NCAT comes in for you, okay? NCAT makes it easy. We do all that work in the background behind the scenes. You click your software, we imagine will be able to interface with these web services. You get results, okay? That's the way we've envisioned it. And so remember, the goal of NatRef 2022 really is to give you stability, right? You've heard maybe it's a dynamic, right? I've heard that a lot. That's why I put that in the title. It's the dynamic reference frame. The frame itself is dynamic compared to, you know, the overall globe, but the goal is to make it stable in regards to the lower 48, okay? How do we do it? With those two products I talked about, okay? EPP, IFVM. Remember, that's the whole point of these reference epochs is stability again, right? They'll be published, those REs or reference epochs, every 5 or 10 years. We haven't quite decided yet. And you'll choose when you update. If there's a new one in another 5 years, that's your choice. We're not the datum police, right? In a perfect world, everyone would stay current, but it's not a perfect world. We all know that, right? So things to think about in preparing for this, thinking ahead. 2 factors really will dictate your frequency of coordinate updates on those reference epochs, right? Your accuracy needs and the region you work in. So Kentucky, not a whole lot of tectonic motion right now, but we got that, that New Madrid fault, who knows, right? But the things to consider, if you're looking at a database of manholes, do you really need centimeter level updates every year? Probably not, you know, but if you want to do that, we give you the tools to do it, okay? And I really want to emphasize this fact here. Just because we're chasing the millimeter in the products that we provide doesn't mean that you have to follow suit with us. We have to do that as a part of our responsibility as a federal agency, that whoever needs to use our reference frames or datums can trust that we provide that super high accurate level so that, you know, their derivative products you know, are going to be able to meet their needs. Okay, so just think about that. We're not telling you you need to do this or anything, right? To update annually. We want you to make your decisions. Really, we want you to just know the epoch of your data sets. Okay, start considering how will you track that, right? Are you going to use a timestamp on every feature in your data sets? GNSS or GPS makes it possible, right? Are you just going to label a year on each data set? It's pretty reasonable for probably the vast majority of the audience today, or something in between, right? It's really all up to you. Again, we're not the datum police or the coordinate system police, but we do want to help you in preparing for this and in embracing it when the day comes that everything rolls out, right? So we expect most of the user community will be transforming your data when you decide to embrace NatRef, right? What will you use? Hopefully you'll use NCAT. Again, whether it's, you know, that ASCII upload, I doubt it, maybe for some small files, our web services, or somehow building your own code with our GitHub code that exists, right? Or integration with your software, because that's what we envision is different softwares tapping into our web services, our APIs, and doing that in the background for you, okay? Taking some of the complexity out of it. We've had one industry workshop this year. I think there was one before that. And I can speak, I know Esri was represented, as was Trimble, Blue Marble that makes a global mapper, and some other ones. Those are just the names I remember. I think there were about 9 participating software makers there, and they want to go that route too. You know, they think it's the best way to do it. Another thing to consider, you could let me pull these words. You could reprocess your data, right? But it's highly unlikely. What does it really mean to reprocess? So let's talk about like one of those hydro-enforced DEMs that Wolpert talked about earlier. To truly reprocess would mean to recreate it from scratch, okay? Start all over with the flight data, new point clouds, recreate all the drainage features. It's totally unrealistic. Think about how long they said that took, right? You're not going to do that. And it's unnecessary for the majority of users, okay? We're going to be doing that with our data, but vast majority of you don't need to do that, okay? So in closing, we'll go over some quick resources. There's my contact info. I'll have it up again at the end. A shout out again to Brian Bunch over at the Kentucky Infrastructure Authority. He is your state geodetic coordinator. I do talk to him a lot and work closely with him, and he serves as like a liaison between your user community and the NGS. So don't hesitate to use him as a resource or to throw a question at him. And if he can't answer it, he knows. He's got my number too. He calls me. We chat quite frequently. These are the real in-depth resources for reading about anything I talked about today and more. We've got new versions out, but what I want to highlight real quick is go to our website. Here's the URL. Check out this tab. We've got these short videos available. They're right on YouTube. They're 5 to 6 minutes, most of them less than that. And we've got a few of these, maybe there's 2 or 3 of these that would be good for this user community. They're about 1.5 hours of lessons that you sign up for, take a quiz, you get a certificate. We've also got our email subscriptions for our different lists. I want to pop up, where'd it go? Where's that little, come on, there we go. Our webinar series. Look for our next one by one of my coworkers. He's going to talk about the NGS geospatial resources. It should be a good one. We've actually got some new pages, getting some of our data out and getting things better organized. Okay, so look for that in our webinar series, I believe for October, maybe it's November, but check that out. And that's it. I'm trying to stay on time here. There's my contact info. If you have any questions, I'll take a look at the questions box if there's anything come in. There again is that feedback for any of our tools. Don't hesitate to drop a line if you want to say something's great, or you say, Jeff, this is really too confusing. We want to hear from the user community about how we can make products that will serve you and for the future datums. So thanks everybody. Hopefully I'll keep us on time. And I love that, yeah, the presentation was pretty epic. Thank you. Thank you, Jeremy. Yeah.
That was great, Jeff. Like somebody else put in there, it's good to have the full explanation of all the reasoning behind what's going into everything. We did have one question really early on in the presentation from Amanda Fairfax. She said, is timestamp always in UTC?
Not necessarily. That really depends on the GPS receiver or how the person using it in the field sets it up. So it could be UTC or your local time zone. Kind of depends on who the user in the field was.
All right, yeah, and yeah, like I said, just good to have that full thing going. And I guess we'll go ahead, and we're right on time here for our 2 o'clock. So we'll get ready to bring in the next presenter. Once again, you are in the 1:30 to 2:30 sessions. I am your moderator, Charles, and bringing in next is Scott McDonald from Esri, who ironically is also sponsoring this session. So Scott, good to see you again.
Yep.
Yeah, if I believe you correctly, I read on your bio that you help help to meet government agency needs, which of course, you know, that is a large part of what Esri does. So go ahead, Scott, I'll push to you. Is there anything else you wanted to say to introduce yourself to everyone?
No, I presented on Tuesday for those of you who didn't catch that session. My name is Scott McDonald. I am a solution engineer. That's my official title. I work with the state government agencies in Kentucky and other states to help them figure out how to meet their workflow goals and their technical needs with ArcGIS. So I'm going to get started. I am going to be talking today about a new product, a a solution, an offering that is part of ArcGIS Online this year. Now, those of you who use ArcGIS Online know that it is a simple, very intuitive software as a service platform for GIS on the web. So you are working in a browser and you are working on Esri hosted infrastructure. It is a cloud platform. So as opposed to either ArcGIS Pro or ArcMap, which is on your own machine, or ArcGIS Enterprise, ArcGIS Server, which is a web GIS system in which you're working on infrastructure that your organization owns and operates. ArcGIS Online is considered software as a service, or SaaS, because you're working on the cloud. You're working on Esri managed infrastructure, and that way you rent what you use. You consume, you pay for what you consume. You pay credits for the analysis tools that you run on the web. So that kind of understanding is important as I introduce this new solution, which is called ArcGIS Image for ArcGIS Online. It is our new solution for imagery hosting, analysis, and streaming in the cloud as a SaaS option. So let's talk a little bit about why Esri is offering this product now and why it's important for organizations. So of course, imagery is such a foundational data source for any information that supports decision-making, gathering insights, monitoring situations, whatever it may be. Organizations have used raster and imagery content forever. Since before we had computers, we had aerial ortho photos and surveys. Now it's a lot more high tech in a lot of organizations. They're using imagery to support precision mapping and what's called reality capture, using LiDAR and drones to get very high resolution, high fidelity virtual representations of what's there. It can take a 3D format. States like Kentucky have been working on 3D base maps, having the ability to have imagery-derived products serve as the base map for your entire mapping solutions. We're exploiting imagery to perform all sorts of analysis, to extract observations, to monitor situations such as emergencies, natural disasters, to gather intelligence, and to gain information about the world as it is from above. We're using imagery to find spatial patterns. Whether or not the final product is in a raster format or in a vector format, it can also be in a graph or a chart. We identify spatial patterns about urban growth, land use and land cover change, agricultural yields, nutrient values, habitat loss. All these different things require the use of imagery on a large scale to pinpoint patterns and have machines look where the patterns are for us. And all of this imagery comes in a lot of different formats, from the classic aerial orthophoto example to the new drone imagery and LiDAR imagery that we see. There's a lot of different modalities and different formats that imagery takes place. To really make the most of your imagery, you're going to need a centralized system. So ArcGIS is designed to work with all of these different types of imagery. And one of the most important parts is management. Imagery management is a key part of search and discovery. Having everything in the right place and knowing exactly how to get to each format of imagery that you have is really key to making the most of your imagery. Esri has long provided photogrammetry tools, and raster analytics have been a huge part of the platform for decades. More recently, we have the concept of GeoAI, where it might be a deep learning package, things like object detection and computer vision being able to let computers do arduous, long, repetitive processing tasks of looking at imagery and identifying and extracting features or determining things about the landscape. Telling those stories in ways that humans, don't need to spend as much effort anymore to get the same kind of insight. The key to Esri's professional level imagery tooling is image services. So with WebGIS, particularly with Image Server, ArcGIS Image Server runs and hosts image services. These are the modern way to empower multiple users simultaneously to be able to work with the same imagery content. And it doesn't even have to be a single image per service. A same image can have collections, hundreds or thousands of images can be mosaicked or layered to provide a really advanced, modern, comprehensive image service. You can visualize and process huge areas of interest with these image services. And because they run on servers, they use server-side processing, they take advantage of that powerful CPU and memory and disk space that a server can offer as opposed to your own computer. And you can create these dynamic image products on demand and have multiple people working with them from around the globe in their browser. We also can run with, wow, I don't know what I did there. We can use image services to run GeoAI in that way. We can use deep learning models to compute really complex analytics using distributed processing, having multiple machines or multiple different cores of a computer running at the same time. We save huge amounts of time. Products and whether it's an analysis tool or a visualization or map production product that may have taken hours or days can now take minutes with the use of image services. And they're available for any kind of visualization and presentation that you might need. Perhaps you want your imagery to be in a focused, very simple web app for a certain use case. Maybe you need to use it in a dashboard. Maybe you have some sort of operational intelligence. You run an emergency operations center, or you report to the governor, or whatever it is. The use of imagery it's really important that image services can be used in different formats, can be disseminated in a variety of ways. And the bringing that all together, what that means is that you're democratizing imagery. You're eliminating the redundant silos of data that we keep on our different machines to instead have the right products available to everyone who needs them with complete control over how they're viewed and accessed and worked with. So ArcGIS Image for ArcGIS Online is Esri's complete workstation in ArcGIS Online that leverages Esri's cloud to support your image services work. You're working with image services just as you would in ArcGIS Image Server, but you're doing so on infrastructure that's managed by Esri, and you don't have that infrastructure management aspect. So let's take a look at how that might, how that actually looks in practice. From a conceptual standpoint, ArcGIS Online can be conceived of as a cloud. It is a collection of machines. As a user, you don't care where the Esri machine is physically in the world. You only care that you have access to it, that you can run it, and you can do the things that you need, and trust that Esri's server management will provide the resources that you need. Just as when you're doing that on Amazon Web Services or Microsoft Azure Cloud, ArcGIS Online is simply about, we store all the content, we provide the processing power for you to run your tools, and you just have to worry about the workflow that you're doing. So you upload rasters into ArcGIS Online just as you would with ArcGIS Image Server. It's a very simple, intuitive upload experience. And then once it's there, you can access all of the imagery imagery hosting and storage, analytics, and streaming capabilities within ArcGIS Online. There's not a ton of new stuff to learn. There's no new software interface to have to get used to. It's based in ArcGIS Online and tightly integrated with that interface. And then you can push out your imagery to the client applications that you need by streaming it as an image service from your hosted data. It's really simple. So to do the streaming, it's really about the workflow that you have. Perhaps you're serving imagery of a construction site, or an agricultural site, or a city. Perhaps you're working with post-event disaster data or natural disaster data. You're serving up orthomosaics in a very formatted, rigid way. Perhaps with the new NAD reference frames, or you're working with multidimensional rasters that have multiple layers of perhaps an infrared dimension. You can publish your imagery as intelligent tiled services or as dynamic services. Those are the two types of image services that Esri supports, and that's the choice that you get to make. On a tiled service, it's a fast performing layer. It retains the pixel information, so the user is performing client-side processing. If they need to interact and do analysis on their side, or they need to apply enhancements to your tiled imagery layer, that's the advantage of a tiled service. A dynamic service is about server-side processing. So your server, well, in essence, Esri's cloud server, your ArcGIS image for ArcGIS Online resources are the ones doing the processing. So that's when you need to do on-the-fly processing. Perhaps you're doing dynamic mosaicing of multiple images and multiple image types. So those are the two options between tiled client-side processing or dynamic server-side processing. This helps you seamlessly integrate your imagery in the way that each different image workflow, each different use case requires. In both of these options, you have full control over the permissions. So who can access, who can upload, who can publish image services, and who can consume the imagery that you are streaming from your image services. And in all these cases, the data is sitting in Esri's ArcGIS Online cloud. There's no need for back-end data management and as if there were, if it was sitting in your own geodatabase. That allows you to eliminate the infrastructure management side of imagery. I know that imagery storage is a major concern and ongoing, it could be a headache for a lot of customers, and it's certainly so. The more that your image collections grow and multiply and exponentially expand over the years as you collect more imagery. With ArcGIS Online's image product, you do not have to worry about that management. You can just work with your image services, trust that they will be fast and high performant, and that they'll be secure within the Esri ArcGIS Online framework, but also very scalable. And as your image collections and your imagery analysis workflows and the number of clients consuming your imagery grows, Esri will be managing the infrastructure for you. And because it's in ArcGIS Online, you get the logging and you get the advanced usage reports that ArcGIS Online has introduced of late. You can keep up with what's going on in your organization, everything related to its imagery in these reports and these logs. And the last thing is that a lot of organizations have integrated logins with your organization's identity provider. Perhaps you use a single sign-on and you've integrated that with ArcGIS Online. That will also persist to ArcGIS Image, opening up the ability for you to leverage those organizational identities when it comes to permissions and security and sharing in ArcGIS Image. ultimately, we're talking about simplified image management. That's what you get when you bring all of your imagery together into a common central system. You can upload a variety of image types from orthomosaics, 3D scenes, satellite-based imagery, aerial orthophotos, even elevation, DEM data, bathymetry data of underwater mapping. And you can bring these all into the same common system, preserving the metadata, preserving all the information about them. The experience for uploading each of these different disparate types of data is the same. The uploading process and the image publishing process is the same. That makes image management, publication, and sharing accessible to everyone in your organization when they need it. And like I mentioned before, we're often talking about huge amounts of data. We're talking about very wide-ranging imagery, either multiple, tons of layers, different images in the same collection, or very large imagery, perhaps expanding throughout the state of Kentucky. If you have Commonwealth data that, such as the one provided by the Kentucky CIT, you have a ton of data to work. You have a lot of imagery to work with. And ArcGIS Image or ArcGIS Image Server are the best ways to work with that, because they are not just working on a single machine, but they spread out the work among multiple machines. That's interpretation activities, image analysis, raster analysis workflows, and all sorts of hosting and streaming processes are easier and faster to do because they are doing so in the cloud. But that doesn't mean that you can still bring in your own machines. You can actually work with imagery that's hosted in this ArcGIS Image platform from ArcGIS Pro. You can bring that into your ArcGIS Pro maps and use all your familiar tools, whether you're doing map production or custom reports. That's all available because it is hosted in your organization, which is connected to ArcGIS Pro. You can use the Python API, the ArcGIS API for Python, to develop custom raster function chains, and I'll talk about that in a second. And to really, if you have that Python familiarity and expertise, you can do everything that you're used to with image processing and some new stuff, because it is all available to you in this centralized repository. And it's all powered by ArcGIS Online. So without needing to acquire new infrastructure, manage new servers, train IT staff, whatever it may be, you don't have to do any of that to achieve imagery processing at scale. And we're really talking about saving time without increasing the costs. It's all about using what you pay for and paying for what you use. You're not paying to maintain your own infrastructure, because Esri is going to manage the software and the cloud resources on your behalf. I'll get kind of into, in a couple of slides, I'll talk specifically about the pricing, but when you host your imagery in ArcGIS Image for ArcGIS Online, you're paying a fixed price to store your imagery. Then there's a common credit system for your imagery processing, analysis, sharing, and usage, consumption. All of that is based on a credit system. You can go further by allocating user budgets. So each of your GIS analysts, each of your managers who uses imagery can be allocated a budget of credits within ArcGIS Online, specifically for the image tasks that they're working with. And there's a credit estimator, so you know what a particular task is going to cost before you do it. We're trying to help you, increase what you're able to do while decreasing costs and making sure that you're making the most of the money that you're spending with Esri. So let's talk about how ArcGIS Image works in ArcGIS Online. There are 4 basic steps. First, you upload your imagery and you publish it to ArcGIS Online. This might be from ArcGIS Pro, or it could be by going into ArcGIS Online and adding content as a new item to add an imagery layer. The second step is to choose between that choice that I mentioned earlier, tiled client-server, client-side processing or dynamic server-side processing image services. These can both be used as inputs to raster analysis. It just depends on what kind of work you're going to be doing and what the kind of imagery is. Step 3 is about adding analytics and deriving insights from your imagery. Perhaps you have a long raster function chain, different raster processing tasks that you need to add together. You're really deriving insights from this stage. You're going beyond the raw imagery data to make a sense of it, to tell the right story and to gain the right knowledge. And then lastly, you stream the imagery. You stream your end products to your users. You are able to decide exactly who should have permission, who can do what with the image products that you're sending, using the familiar role-based, group-based permission sharing in ArcGIS Online, or you can stream imagery products to the entire organization. So a big part of ArcGIS, or of any image processing workflow, has always been spatial analysis, and particularly finding spatial patterns. So ArcGIS Image Online brings in the concept of raster functions that you're probably familiar with if you've done imagery work before. Raster functions, there are more than 150 different ones that Esri offers to choose from, and you can run them on their own or chain them into a raster function chain to make it a very specific, tailored workflow, a chain set of functions that do exactly what you need to get the most out of your imagery. And then with raster function chains, you can share them as raster templates. And templates are amazing because they cut down the time that it takes to do a custom workflow. If I need to get a workflow out very quickly to my users who don't know how to make it, I make it for them, I save the template, and then I share it on the web in ArcGIS Online. I can even work with predefined raster function templates that Esri has created, or perhaps other users around the world have created and shared to ArcGIS Online. And in every case, I know through the credit calculator how much my process is going to take, how much it's going to cost me in terms of credits to allow me to control what I'm doing. You can go a step further with deep learning. We have a growing list of pre-baked models that we offer for imagery through the ArcGIS Living Atlas of the World, detecting objects like solar panels or swimming pools, classifying buildings, classifying roads. These models are just as accessible as any other layer in ArcGIS Living Atlas of the World. And when you do this, ArcGIS Online can spin up multiple CPU processing cores at the same time to handle the extra load that it takes for a GPU-based deep learning package. This is really a great way to modernize your imagery production workflows without needing to make complicated investments, expensive investments, without having to get a degree in deep learning or get a degree in spatial data science, and to really start taking advantage of these tools now. So I want to wrap up by talking about how you get started. It's really easy. It's very simple. There's not a lot of steps. I'm used to working with ArcGIS Enterprise and there being a ton of steps to get started, a lot of complicated things to make sure that people understand. This is really simple. You just license ArcGIS Image as capabilities for users in your organization. So you start with anyone who has a creator user type. And the user type of creator allows you to create and to publish services in ArcGIS Online. As an administrator, you add an ArcGIS Image for ArcGIS Online capability to their user type license. That will allow them to publish and manage imagery in ArcGIS Online and to perform the image analysis that's available there. That's going to be $700 per user per year as a flat cost. After that, you use credits for services that you run within ArcGIS Online. So imagery storage is 1.2 credits per gigabyte per month. the cost of credits for dynamic imagery hosting with your dynamic image services is calculated based on the number of images and the number of days that it's been stored. And then your imagery analysis, all of your raster function templates, all of your raster processing, that is calculated by multiplying the number of pixels that are involved in the process and the complexity of the analysis. So a raster reclassification process is going to be cheaper in credits per pixel than a very complicated deep learning process. Hopefully, we are making this as transparent and easy to understand. And as I mentioned, that credit calculator helps you understand exactly what you're paying before you run it. So I'm going to put a couple of resources in the chat that are a couple of resources, a couple of guides to getting started with ArcGIS Image for ArcGIS Online. The first is just explaining in greater detail what it is. And then if you want to get started, I am going to send you the guide for implementation as well. We'll give you the steps and all the best practices that can help you get set up, understanding how to choose between tiled and dynamic image services, whatever it may be. We are here on an ongoing basis, whether it's with your account manager and your solution engineer, or talking with Esri support, Esri services. We really want to make sure that you get the most out of this platform and really reach new heights with what you're doing with imagery in ArcGIS. So thank you very much for the opportunity to chat with you guys. I've been really amazed by this conference, and I've learned a ton, and I really appreciate the opportunity to be a part of it. So if you have any questions, I'm happy to answer them.
Thanks, Scott. It was a very informative session. I don't think we have any questions yet, although Dr. Drew decided to throw in there that Kentucky's also working on a 3D subsurface geology information. So there's a little plug there for Dr. Drew. But yeah, again, there's just so many great tools that can be added on or subtracted as needed. And this is another step in the further direction. And I think these are great solutions for large organizations.
Yep. We have a question about direct access to major imagery data sources. Yes. For example, you can access Landsat, and that has been an ongoing process for Esri to provide. It's provided through the Living Atlas of the World. So it's just as easy to add into your imagery, into your maps and your image information products, just as it is with any other imagery. There's quite a lot of it. Multidimensional rasters are available. Orthophoto content is available. There's a lot out there to explore.
Let's see what else I was going to say. Just a reminder, of course, that this session was sponsored by Esri. And we are going to have next session at 3:30, which will be the mobile technology shift, expand your appraisal landscape, followed by ArcGIS field maps. And then we will have our closing remarks at 4:30. Let's see, Dr. Andrews also commented that this is exciting, a lot of options being opened up with 3D all at once. And is there anything else I forgot to mention, Andrew?
No, sir. Appreciate it. Thanks for stepping in.
Yes, I am Jessica Lott right now.
Did a great job.
So.
Yep. Sounds good. All right. Yeah, we'll see you all in another 30 minutes. Take a break and be back for the last session and then closing remarks at 4:30.
All right. See you, everyone.